All right, if we're asked to simplify this expression, we're dividing two radical expressions here. The first thing we can do is cancel common factors. This is with any expression like this, any rational expression. The radicals don't really do much. It's important that these are both under a square root that we can do this. But what I mean is we can cancel, for instance, between the 16 and 108, any common factor. I found there's a common factor of 4. So I'm going to divide the 108 by 4, and I get 27. I'm going to divide the 16 by 4 and get a 4. I then, with the k's and the a's here, I'm going to cancel the k's. For instance, in this case, I'm going to cancel 4 k's out here, and I'm going to cancel 4 of these k's, leaving me with a k to the 8th down here. And with the a's, I'm going to cancel 6 a's up here with 6 of the a's down here. I'm left with 2 a's down here in the denominator. So what I would have after all of that canceling, up in the numerator, I'm just left with the square root of 27. That's the only factor left. Down in the denominator, I have the square root of 4k to the 8th and a squared. Okay, that right there is really the only trick in this problem that has to do with the fractional or dividing part of it. What I'm going to do now is just simplify the numerator and simplify the denominator separately. In this case, what I'm going to do is I'm going to rewrite 27 as the square root of 9 times 3. And then I'm going on the bottom, I have nothing really to do. I actually can take the square root of all 3 of these factors. The square root of 4 is 2. The square root of k to the 8th is k to the 4th. And the square root of a squared is just a. So I've simplified the denominator in the bottom. In the numerator in the top, I've split off this perfect square, but now I'm going to square root the 9, and that will give me a 3 on the outside of the radical. I still have that 3 left on the inside. And in the denominator, I have 2 times k to the 4th times a. And this is the final simplified answer.